In the previous class, we talked about the construction safety and sustainability, and a concept that is pretty close to the safety is the risk. So one of the important concepts that always kept in mind is the risk factors, right? So you don't provide unsafer environment, so as you don't provide any riskier stuffs as well, right? So in this lecture, we'll be looking into some of the risk associated with RMC plan. Right. So risk is there in almost every businesses or every projects. Even in construction, there are multifarious activities that has associated risk, right? So, but we'll take a look at some important element called RMC called ready mix concrete. Right. So, what are the important risk? In fact, I've collected a lot of details about the risk associated with RMC plants. Um, to put in a nutshell, there are 120 types of risks, but all the risks are not pretty severe, but only 10 percentage are few are like in terms of severity, right? Few are in terms of moderate, like it could be severe when you don't deal with it in the initial stage itself, or few of them are not very highly riskier, but but keep in mind like that can delay the process or the product delivery or something like that, right? So that's all regarding the risk. Let's take a look at some of the concepts pertaining to risk, right? Um, RMC plant is, one of the important thing nowadays. Like they produce, huge volume of concrete and can used for multi-story buildings and a bigger construction or heavy infrastructure, right? And it's very important to take a look at that because most of the projects nowadays, even small scale construction projects, even they use RMC. They get concreting by RMC, right? So it's unavoidable, and there are a lot of associated risk with that. Like to begin with, like RMC plants, you can see the drums that rotates continuously, and they have a calculation to do that, right? So it is not done randomly. There's a calculation to do that so that like the concrete does not sets in. Like so what happens if the concrete sets in the drum itself and will not be useful for the construction site. And the kilometers they calculate from the RMC plant to the site location, and then they'll add admixtures. Generally, it's retarders, when which the concrete has a property to set in a couple of hours to 10 hours, right? So in order to avoid that, people use retarders. So those things are pretty much an process or general, objective to to transmit concrete from one place to another. But then like there could be some delay in the traffic, or the routes were blocked, and the estimated time gets exceeded, so your concrete started setting. So those things are kind of a risk, right? So risk associated with the RMC. So if you own an RMC or RMC truck, then you will be considering all these things in much detail. So this is very important. Kindly pay attention to this. There are three important characteristics or three important components of risk management. So one is the risk identification. First, you have to identify risk, right? So what are the riskier thing and what does not contributes, or what you can make it pretty easily without any problem. So that's all unriskier thing. But what happens if something you don't do it or you delay it can be detrimental to the project itself. So identify those kind of risks and you prioritize them. As I told you, what cause severe damage to the project and what cause moderate damage to the project, or less severe, like maybe it could leads to detrimental factor, or it can be a dormant itself, like so that kind of a classification you can do in a risk prioritization. Then proposing risk mitigation measures or solutions. So first you identify a problem, then you prioritize or categorize the problem, then finally you just look into the mitigation or the solution to the risk problems. Like how do you cannot prevent them, but you can provide a remedial measure to that. Say for example, as I told you, the time taken from one place, the RMC moves from, I mean, ready mix concrete truck moves from one place to another. If it is longer, then you add suitable dosage of retarders. Right. But if you ask me, the final product is good or bad, it's debatable, because when you add too much of retarders, the original characteristics of concrete may not be retained. So it gets altered in the drum itself, and when it used in the construction side, it may not have as comprehensive property or sound quality as the original concrete. So there should be a compromise between that, right? So all these things you need to take care, and those things can put under mitigations measures. First is risk identification. In fact, this is a project that we proposed some years before. Like first is like that we have identified few RMC plants, and we have even visited them, and we have categorized RMC plants itself, like light, medium, and heavy. Like some of the RMC plants where they produce only very few tons of concrete, or patching of concrete is done in very few quantity, then we categorize them as light. Like for example, some RMCs nearby this Mambakam regions are pretty much light RMC plants, where they can accommodate a maximum of one or two RMC trucks. Whereas medium thing is pretty much bigger than the light RMC plants, when which some RMC plants, they have their own batching units, and then they have their own processing, material processing units, and so on. So they can be put under medium, whereas heavy is the ultimate, like which has got a huge volume of concrete produced, and something like most of that will be like the higher. Most of them will be governed by the premium construction or premium industry called Romco and JSW and something like that, right? So they have the huge, RMC plants or something, right? They do it in a huge volume. Example is ACC. Their prime business is the RMC. So we have visited that, and then we have got a good, opinion, or just something like an expert opinion of experts. We learn from the experts, and this is pretty much called as constructability review in a technical term, but it is just like expert opinion and something like that. We have got the expert opinions, and then we get into the categorization, not prioritization, categorization of various risks from their, like from the from our visit, as well as from the experts opinion, right? One such thing that we find, which were not, which we have not realized earlier before going to the site, is that many, RMCs use automated batching facilities. Like automated batching facilities will be perfect, will not have much flaws, whereas manual batching may have a flaw because of the manual dexterity, and it requires continuous monitoring and something like that, right? And that is one particular risk. And even in automated thing, the process goes really well if there isn't any problem with the automated system, right? So if the automated system has inherent problem, or there is any external problem, like the hardware goes away, or the the software gets corrupt or something like that, then it will be a huge detrimental upset to the RMC with an automated batching system. So these things you can put them under, if manual thing, this problem, if automated batching, and this is the problem, and something like that, right? So that is what we sort them under various categories, right? No single solution can be given to all RMCs, because most of the RMCs are unique. So we need to fragment based on the size, and as I told you, light, medium, heavy, and also the nature of operation, being a manual or automated or something like that, right? So that's the risk identification. And risk prioritization, this is a very, very important thing. Not only identification matters, but prioritization matters. Like how do you sorting is not a prioritization. Remember that sorting is just categorization. Prioritization is like you give a ranking, like which risk probably has an huge influence, or would could cause huge detrimental upset to the particular project, and something like that. So that's pretty much in risk prioritization. uh, and then like you can categorize as severe to light, or you can even categorize them to rare to almost certain, right? So something that happens pretty certain, we put them as certain, and something may be happening in 1 in 100 chances, then you can put them as a rare or something like that, right? But then like the severity may not be the same. Suppose a rare risk can cause a huge upset or huge distress to the company itself, right? Then it comes under severe, but then in terms of occurrence it will become the rare or something like that. So you cannot always ignore any types of risk. All the risks are serious, you have to deal with, but the severity of that risk need to be understood, right, in detail. Then the consequent table, as I told you, it's insignificant to catastrophe, is what I said about severe to less severe or moderate, light, and something like that. Then a questionnaire is made, and then like we have done something in SPSS. In fact, SPSS is kind of a pretty old now. It's almost kind of not used nowadays. Predominantly, people use R software and Python nowadays because SPSS is a proprietary software, whereas an R and Python are open source, so anybody can use it. Something. And this is a prioritization table. So this is kindly pay attention to this. This is very, very important. Uh, Point number one is like political risk. Like here, political, we don't talk about politics, but in terms of legal issues and legislations and something like regulations and laws and something like that, right? So we put them as political risk, R1, R2, R3, and this is identified and classified. We have not prioritized. We just sorted, like we have just categorized that. After that will be the prioritization. Like prioritization will give us like the empty fields in this table gets filled, right? So the probability of occurrence, we have talked about rare, unlikely, and possible, and likely, and almost certain, right? So I've given some five scale, or you can even use numerical scales. Like you can use Likert scale, Lakert, Likert scale, right? So you can categorize the rare is, you can put it in 1, unlikely is 2, possible is 3, and likely is 4, and almost certain is 5. So 5 out of 5 will be a certain, right? So you can even numerically put that. And consequences is pretty much important. We can talk about insignificant, which can correlate with rare. Rare and insignificant will not be a big problem, but rare and catastrophe will be a problem. Like the valve failure in Union Carbide company, people will not have thought like that will be a huge catastrophe to the uh, people, and it be still remembered in history called Bhopal tragedy. That particular valve is probably like 500 rupees that time. They could have replaced it so that they could have avoided a huge disaster. But then it's kind of a rare probability. Probability of occurring that in a industry is pretty rare, but it is highly catastrophic. So people should really understand that, right? If they felt that methyl isocyanate will leak and will kill a lot of people, then they could have even put bigger measures and they could have prevented it in the earlier stage. And if they would have prevented that in earlier stage, nobody would have affected or even know about the Bhopal tragedy, right? So there won't be any tragedy. Like the Union Carbide company could have still exist in operation now, right? So that's something like you should really put in like, and this is pretty uh, you know u- useful for construction projects, because in construction projects we know few things which we are pretty sure about it is not safer or riskier, and few things we may think it might be riskier, but we it not have a huge influence in the project or the final project. And then something which is pretty rare, which people would not have even anticipated, but could be a disaster. Like for example, if they don't do proper calculation of the water table, groundwater table, and when they dig the soil, the water gets percolate, and that's a non-calculated risk, right? Or without experience, people would have done the tendering process, and then finally they get this and something like that, right? And then identify risk is like project managers have to pay attention to the work done by the subordinates, especially the laborers. If they orient a column or they tilt a column, then will be a disaster. Then the contractor have to completely replace it, and they incur huge loss, right? So that can be moderate risk, but not riskier in the sense like the absenteeism of the laborers, because generally there will be a standby, so they generally don't have much influence. But then if they don't have a huge labor shortage is a different issue than the absenteeism, right? So those can be of insignificant consequences or something like that. But then it's riskier if the person who's skilled do not turn up for so many days, then it'll be riskier or something like that. So as simple as that. So you have to categorize them like political risk and contractual risk and something like that. Next is very important. Then you provide the prioritization concept. Like insignificant with rare is pretty low. Rare as rarely occur and insignificant will not have much influence. It's pretty low. The risk is pretty low. And rare and minor occurrence is also pretty low. Whereas rare and moderate is something pretty low, but you need to really look into. And rare and major, occurrence, rare occurrence, and this is you can see this is probability and consequences. This is probability of occurrence, and this is the consequences. Rare but catastrophe will be a very significant. So you need to really take a look at that. Then unlikely and insignificant is pretty low, unlikely in minus. You can see very low, and very low. So this is kind of an upper triangle if it is a matrix. Then probably you can see this is low, and this is something like that. And you can see catastrophe is rare is pretty significant, and whereas unlikely in major is significant. I mean, even catastrophe is significant for all. And then possible occurrence, and then even moderate risk is also the pretty much significant, and so on. Likely occur, even minor is significant, and almost certain, even insignificant itself is also significant, right? And then you can talk about lower triangle of high. After significant, it is high. So possibility of catastrophe is pretty high, so we need to take a deep understanding of this. Then likely, even in likely, major is also pretty high, and almost certain, even moderate risk is also pretty high. So this is a risk prioritization matrix. And let's take a look at the consequences. The one that is striked, no, that's not gonna be very much in place, whereas the one which is highlighted in yellow color or should be looked in very detail, right? So that's why we generally prioritize risks based on these things or something like that. So this is very important. Next, let's take a look at. Okay, so some of the examples I can give you is earthquake is a risk which has less probability and more consequences. This is pretty much like rare and catastrophe, something, or unlikely or catastrophe, or unlikely or even major, something like that, right? You can talk about that. Then missing spare parts is a risk which has more probability and less consequences. You can always find out spare parts from the near other contingents or other assignments or something like that, right? So that is probability of occurring is more but less consequences. But concrete choking in a formwork is a risk because that will create a additional pressure on the formwork, and the formwork fails and something like that. That is more probability and more consequences. The occurrence of this is pretty high. That is why people use vibrator to move the concrete or compact the concrete, or make the concrete to go inside the reinforcement or congest a reinforcement or something like that. So the occurrence is more probable, like this almost certain, and its consequences is catastrophe. So it's almost certain and consequences is catastrophe. It's pretty high. So these are some of the examples, and how do you sort them and rank? It's very important, right? So the high probability risk are first initially identified and sorted out. Then high consequences of risk also sorted out, like uh, consequences in the sense like are very you know um, the occurrence, right? So insignificant is not a very high consequences, but catastrophes are very high consequences. And the risk which are having high priority of occurring and high consequences are occurring are major risk. Like in this case, these yellow colors are highly occurring, or it has higher risk. Whereas you can see the low can be put under moderate risk, and this very low can be put under less severe risk or something like that. And then we make a graph, right? So let me show you. This is wrongly designed layout. This is a risk in an RMC where the material movements are not clearly defined or not optimized. Then you can see the mean is pretty much 9.10 in standard deviation, and the count is 20. So 20 RMCs, and this are the frequencies, right? So it comes under this particular thing. It can be put under moderate risk. Whereas delay due to traffic, right? This is one of the important, problem, like the traffic in an urban sector, where the if the construction project supposed to be in an urban area, then transmitting materials to that is pretty riskier, and especially the RMC. Taking concrete to the congested areas and also to the you know um, urban infrastructure will be very difficult than it is in the rural sector or in the outskirt, right? Somewhere. Then breakdown of machines in the RMC plants is also considered to be a thing, but it is not as heavy as the previous thing, right? And then high probable risk, like this, we have criteria some 16 thing. One is the not doing major overhauling service. So hauling processes is also hauling is just like taking care of the materials and depositing and transmitting, right? So overhauling services, not keeping hydraulic equipments free. So when the hydraulic equipments keep on running, then it will be disaster. The reason is that there's something called fatigue issues in machines. So machines has to be given some idle time for effective usage, something like that. Right? And not availability of safety equipments and over exertion. Over exertion is continuously, using the equipment day and night. Right? Then non-availability of spare parts is number 5, and irregular quality standards and incorrect use of admixtures. Because I told you that's a very important thing. So there should be a calculated quantity of, the retarders should be used. If they have not used it properly, then there'll be a detrimental, right? And then irregular quality standards, I mean, improper specification of RMCs and incorrect mix design. So concrete mix design is a huge thing. We may do that in ACT, Advanced Concrete Technology. We may do it for 5 marks or 10 marks, but then like if you do it properly in a real time scenario, you can save millions of rupees, something like that, right? So mixed design is a very important thing, right? That's why they don't generally reveal mixed designs of a particular, because it will become a trade secret for them. They would have done a lot of batch trial mixes, and then they would have arrived at an optimum mixed design. So it's specific different from one RMC to another, but it not be varying too much, but within the range of, they can, within the range of the standard deviation they can provide. And then no flow through pipes during discharge, like the concrete gets choked during the discharge. An unskilled person to work, and wrongly designed layouts, and frequent breakdown of machines, and traffic problem, and use of new technology. Like as I told you, automated system, and you rely everything on automated system. At one instance, if something goes wrong, then you will be in a great disaster. As a company, even the company will become will incur huge upset. And then investment risk, like we use the older technology and we don't bother to use some modern or invest in modern technology, so the return on investment on olden technologies will be less, and the productivity also be lesser in an RFC plan, something like that. So these are some high priority risk. And high consequence risk, we talked about probability of occurrence of this, and this is consequence, like what happens if the risk happens. Then, for example, no periodic checkup of plant and machineries. Like we take about 5 accident at plant site, like so that is pretty less. Whereas 13, we can take about 13 is improper moisture compensation, right? So those could be an highly consequential risks. So you should really keep in mind, right? So this is something like we have tried some time before on RMC plan. You can um, use these concepts to model risk for any construction projects or any projects even, right? Something. Then we talk about once you categorize that, you prioritize them like based on the mean. Mean is a mean of occurrence, like it occurs in 9.8, like out of 20, right? So non-availability of spare parts and incorrect use of admixtures and delay due to traffic. You see, traffic delay is number three, and whereas if you take a look at this here, not in here, here. Traffic delay is 14, which is not as high priority risk as investment risk. But then, like when you talk about ranking them, then that will be pretty much because that occurs most of the time. And risk mitigations, and once you identify these risks and you prioritize them and you solve them or you mitigate them based on the severity, right? So if I'm a researcher, or if I'm a personal working in an RMC responsible for the risk thing, then I'll just inform the spare parts team or the stationary team to always keep the spare parts ready and to check, or at the end of every day I check, so that the next day they don't have this particular rank number one risks. And at make sure I'll talk to the quality control team, and I'll ask every batch you just check, because it's their role to check and certify whether the concrete they produce is uh, quality or within the standards, something like that. So we'll be mitigating this risk in the beginning stage, or at the juncture where you generally produce the materials, not at the later stages. So if you do it at the later stages, then you have to really regret. It'll be a mistake by then, right? And mitigation is all about how you you know uh, rectify that, and that's all those things are like mitigation strategies, right? And mitigation strategies, it'll be different from different organization to organization, but there should be some quite common goal. The goal is to mitigate the risk, something like that, right? All right. So we talk about accidents and RMC plans. It was receiving raw materials without verifying specifications, and over-exhaustion is overuse of machineries, and to mitigation is promoting automated and robotics in construction and something like that, and frequency of breakdown of machines, like proper maintenance, periodic maintenance should be done, and traffic maybe 3 to 5 hours. Nowadays, like we have a Google Map, so you can find out the current traffic position scenario, right? So probably you can plan accordingly. And GPS in RMCs, like, and then we use high range water reducers or super processors to make the concrete more fluid, and then adding retarders and something like that. Then the pipe gets choked during discharge of concrete. If it is for high rise concrete, then you should have additional pump to raise the concrete to the top floors or upper levels or something like that. And incorrect mix design, computerized batching is nowadays preferred over the conventional or manual batching. In non-availability of spare parts, you can even put that in the budget. Without this thing, then it'll be a huge risk for them, right? And expert service for maintenance should be given. Expert's opinion. That's why there's something called inspector, quality inspector, and quality assurance inspector, whose job is to make sure that there isn't any severity risk that popping up during the processes, and all those things, like something like that. So we have taken 120, as I told you, we have taken 120 risk, and out of that, like 16 is considered to be the catastrophic or very severe, and other things like the driver's absenteeism and all also a factor, but it'll be insignificant and rarely occurring, something like that, and that's it, right? Probably you can use this particular knowledge to model risk for any construction projects or any projects even, right? All right. Then we have taken all these things out of 40 questionnaires of 12 risk associated assorted, and then we have provided mitigate measures, right? So to those 12 catastrophic risks. Somewhere. And then you can even talk about the other types of risks. Probably if some researchers follows this and they can really find out other risks. Not much catastrophic. issues because we have spent a lot of time on finding that, but some minor issues, some major issues, or even rarely occurring issues, risks you can find out.